Okay, here's our review for our Algebra 2 Honors, Chapter 7, Quiz 1 review. Starting off with a compound interest question. You invest $1,776 in an account that pays 7.25% annual interest. How much money will you have after 13 years if your interest is compounded monthly? So hit pause, try the problem, come back for the explanation. Okay, here's the explanation. You should end up, just so you can check yourself to see if you can continue on without the explanation, should be approximately $4,515.66. The answer key that I gave you guys on this worksheet, I believe, had $4,545. It depends all on the rounding and where you round, if you rounded 3 decimal places or 4 decimal places. So as long as you're in the journal area, it's okay, and as long as you show your work. If you did not show all these steps, then I might go, I don't know, they might have made a mistake somewhere and I can't see it. And that's why their answer is different than mine. So it's always best to show your work. Okay, so in the blue, we plugged in all the numbers from our problem. 1,776 is our P. P stands for principal. Our rate is 0.0725. We need to move our percent into a decimal point. So that's why I moved 2 over to the left to be 0.0725. Divided by, in our equation it says N. N means how many times a year is it being compounded. In this case, for this question, it was monthly. So that means our N is 12. So then in our exponent, it's N times T. So 12 for our N, and then our time is the 13 years we have our money in our account. So it's 12 times 13. So the blue is our base equation with all of our numbers plugged in. In the green, we just simplified what was in the parentheses. Came out to be 1.006, and then to the 156th power. Then the red step, we did the actual exponent part of it, 1.006 to the 156th power. It gives us 2.5426. And then the final answer in black is 4,515.66. Okay, so this is our first compound interest question. Our second one, very similar to that. Again, give this a try. Come back for the explanation. Okay, for this answer, you should get, again, approximately $19,000.62. If you got that, great. If not, here's the explanation. In blue, again, we plugged everything in. Our 10,000 is our principal that we started off with. And then again, our percent is 0.036 because we moved the decimal place over 2 places. This time it said it's compounded quarterly. Quarterly means it's separated into 4 parts, so it's being compounded 4 times a year. So that is our N in both cases. This time, we started the savings account on the day you were born, and we're stopping it when you go off to college 18 years later on your 18th birthday. So our time is 18 years. That's our blue step. In our green step, we simplified what was in the parentheses and got 1.009, and then to the 72nd power. Then we did 1.009 to the 72nd power, and then in our red step, we got 1.9062. And then times 10,000. Don't you dare plug that in a calculator. You should be able to do that without a calculator. All you do, you have 4 zeros here. So you need to move the decimal place 4 places back. So then your answer is 19,062. And don't think I didn't see you plug that in your calculator. You should know better than that. All right, next problem is a very similar problem, but we're using a different formula. And that's because of this word right here. Compounded continuously. That means it's always compounding upon itself. We don't wait till the end of the month to compound what we're adding in. It's always being added in and compounded all the time. This is better. We get more money this way. So we invest $2,300 in a savings account that pays 4.8% annual interest. How much money will you have after 10 years if your interest is compounded continuously? And here's our equation. Y equals P e to the RT. So we're going to have you give this one a try on your own and come back. See you in a few. Okay, for this equation, you should get approximately somewhere around $3,717.03. I'm a little off from where I was on the answer key, but that's again because I rounded differently somewhere along the way, or rounded at a different decimal point. Okay, plugging everything in. Again, our P stands for principal, what we start off with. E is that irrational number we've talked about in this unit. And then our rate is 0.048, because again, we moved the decimal place over 2 places. And then our time in this case is 10 years. So our green step, we multiplied the exponent. Again, don't use your calculator. You can do that without a calculator. You just move the decimal place over 1 spot. So it becomes e to the 0.48. Then we take e, using that button on our calculator we did, and then to the 0.48 power, and we get 1.6161 in red, times the $2,300 we originally started off with. And that means after 10 years of compounded continuously interest, that we should end up with $3,717.03. So we got $1,400 extra dollars by just putting our money in a bank and just sitting there for 10 years, and we made $1,400 off of it. Yay us! Isn't that exciting? Okay, here we're doing a graph. So f of x equals 2 e to the x plus 3. We're going to start off with trying to fill out our xy chart. We're going to be doing -1, 0, 1, and 2. Also, right away, you can pick out what your asymptote is, because you're going to look at your original equation, and it's your Kelly point. Your Kelly point here is a +3, so our asymptote is +3. But again, don't just write 3. If you just write a 3 like that, it is incorrect, because we need it to be y equals 3. And I'm going to go ahead and graph that on our graph. Okay, the rest, you're going to plug that in your calculator, get out your x and y chart, figure out your graph, do your domain and range, and come back and check it out in a moment. Okay, here's our x and y chart. Again, I got that from the graph on the graphing calculator, or sorry, the table on the graphing calculator. Then here's our graph. We couldn't quite fit the point to 17.8, but I fit it in way up there, again, putting an arrow on there. Down here on the bottom, we come close to touching our asymptote, but we do not touch it. Never, ever, ever, ever touch it or cross it. And then our domain means what numbers can we plug in. So what are our x values? So we look across the x-axis, and we're plugging in all of these numbers because they all have a point. So our domain is all reals. Our range, what numbers can we get out of our equation? Well, if we're never going to cross our asymptote right here, we're never going to get anything that is less than 3. So that means our range is y is greater than 3. Do not put an equal to on there. It is not equal to, because again, we do not touch it. So if you notice, our range is going to pretty much always be what our asymptote is. Okay, so let's give another one a try. Give this one a try. What is our asymptote on this one? Look at the equation. We got 1/2 e to the x minus 1. That's correct. Our asymptote is y equals -1. So we're going to go ahead and graph that on our graph. Okay, again, try and do this all on your own. Graphing it in your graphing calculator, coming up with your table, graphing it. Check back to see how you did. Okay, here's our graph. You can tell that this is a lot tinier. Our numbers are our points are a lot closer together. Why do you think that is? Go back to the equation, form a hypothesis. Why do you think our points are a little bit closer together on this one? Ah, yes, you are correct. It's because of this coefficient here, this +1/2, just like it was when we did absolute values and parabolas and square roots and cube roots and everything else. That means it's a vertical shrink. It compacts them down a little bit more so they're a little bit closer together. So here is our graph in green. Our domain is all reals because you can plug anything in. And our range is everything greater than -1. Okay, now we're not going to do it with a base of e anymore. We're going to do a regular number base with an exponent. So again, what is our Kelly point in this case? I don't see a Kelly point. So that means our asymptote is going to be 0. So it's going to be y equals 0. Okay, give this one a try, come back, check out the answer. Okay, here's our graph for this equation. If you notice that it is a reflection across the x-axis, and why could we have predicted that from the beginning question? Huh? How could we have done that? Well, again, it's because of this coefficient. Because that coefficient is negative, that tells us it's going to be a reflection. Just like it did with absolute values and quadratics and square roots, cube roots, and everything else we've done this year. Okay, we pick our points from our chart or our table on our graph. Our domain is all reals because we can plug in any value we want here for x. Our range is going to be y is less than 0 this time around because this is going down. And our asymptote, again, is y equals 0. Here's your graph. I believe we have one more. Give this one a try. Come back for the solution. Okay, here's our graph and our domain range and asymptote that we should have. Again, our asymptote is from our original equation. It's our Kelly point, this plus 1 back here. So it tells us our asymptote is going to be plus 1, which also has to do with our range as y being greater than 1. Our domain, again, is all reals because we can plug any number in. This is called an exponential decay because it's going downhill. How could we have seen that from the beginning of the problem, you ask? Well, the number that's being raised to the power is 2/3. Because that is in between 0 and 1, that means it's going to be an exponential decay problem, and the graph is going to be going down. Okay, next one is a word problem. Scientists use traps to study the Formosan subterranean termite population in New Orleans. The number of Y termites collected annually can be modeled by Y equals 738e to the 0.345t, where t is the number of years since 1989. What was the mean number of termites collected in 1999? Okay, give this one a try. I'll be back in a moment. Okay, here's this problem. In the blue, we plugged in the 10 for the number of years from 1989 to 1999, so that's 10 years. Again, do not use your calculator to multiply 0.345 times 10. You just move the decimal over 1. So here in green, we have to the 3.45 power. In the red, we've done the e to the 3.45 power, and we got 31.5. And then we take that times 738. So we should end up in 1999 with a mean number of 23,247 termites, which is absolutely disgusting. Okay, next problem. Evaluate the logarithms. Show all of your work. Take a moment, do this, hit pause, come back for the solutions. Hey, welcome back. Nice to see you again. So mentally, I write each of these equal to x. So I want 4 to the x power equals 64. So 4 to what power equals 64? That's one you should know. If you don't know it, you're going to have to multiply 4 times 4 times 4 times 4 times 4 times 4 times 4 until you get as many 4s as you need. Okay? Otherwise, you should know that 4 to the 3rd power equals 64. Next one. Set it equal to x. We have 8 to the x power equals 4,096. Again, this one you might not know off the top of your head. I would not expect you to. So you might have to multiply 8 through a couple times in order to get 4,096. And if you do that, then you get an answer of 4. Next one. Set it equal to x. We have 32 to the x power equals 2. So this time we went from 32, which is a bigger number, down to 2, which is a much smaller number than 32. This tells us something. What does it tell us? It tells us that we're not squaring or cubing or fourth powering anything. We have to root it to get our answer. So that means our exponent is going to be a fraction. So what root of 32 is 2? Well, that is the 5th root of 32. So our answer is 1/5. So 32 to the 1/5 power gives us 2 as an answer. Same thing is true for the next problem. We have log base 125 of 5, and we're going to set it equal to x. So it's 125 to the x power equals 5. Again, we went to the big number of 125, down to the much smaller number of 5. So that tells us our exponent has to be a fraction because we're rooting it. So then we need to think backwards. What root of 125 is 5? And that is the third root. So our answer is 1/3 for this one. Okay, next question. Find the inverse of each function. Show all work. Give these a try. Okay, first one. First step in finding the inverse is switching the place of the x and the y. So we're going to get x equals log base 24 of y. Excuse me. Then we always want to solve for y when we're doing inverses. We want to solve our next equation for y. So we realize, this is in log form. The only thing we know how to do with log form right now is to plug it in and put it into exponential form. So we have a base of 24. That means our exponent is over here by itself, so that's x equals y. And looky there, that's exactly what we wanted. We wanted it to be solved for y, so that is our answer. Part B. Again, first step, switch the places of the x and the y. So x equals 4 to the y plus 2. Again, since this unit is on logarithms, I bet you we're going to do a logarithm here. So we're going to do log base 4 of x equals our exponent of y plus 2. Now we want to solve the equation for y. So in order to solve the equation for y, we just subtract 2 to both sides. So we get y equals log base 4 of x minus 2. And that is your inverse function. Yay! So give that one a try over here with our last problem. Y equals e raised to the power of x minus 6. Again, you switch the place of the x and the y. Now we know that with e, what do we use when we inverse an e? We use the natural logarithm, the ln. So we're going to do the natural log. Again, we don't write the e down as our base, but we know it's our base, of x equals y minus 6. You want to get the y by itself, so we add 6 to both sides. And we end up with the natural log of x plus 6 equals y. And then that is our inverse function. Yay! Okay, next one is our graph for a logarithmic function. A couple words of advice before you get started on this one. First, pick out your Hank and Kelly point. Your Hank and Kelly point is -2, -3. And then after that point, forget about Hank and Kelly for a while. We're kind of going to cross it out. So we want to do y equals log base 3 of x. And that's going to be our base function we want to graph right now. So we're going to turn that into exponential form. So we have 3 to the y equals x. So in our xy chart, we're going to do something we don't do a whole lot in math. And we're going to plug them in for the y this time around instead of the x. So we're going to have 0, 1, and 2 that we're going to plug in. So we plug those in. 3 to the 0 power is 1. 3 to the first power is 3. And then 3 squared is 9. Now we're going to graph these points. So we're going to graph the point 1, 0. And then 3, 1. And then 9, 2. But do not connect the dots yet. We're just putting those as placeholders right now for us. Now we're going to go back to our original equation, and we're going to look at the Hank point, because the Hank point is going to tell us our asymptote for this problem. So our Hank is -2. That's our x value. So our asymptotes when we're graphing log functions are going to be vertical asymptotes, going straight up and down. Now we're going to take into account the Hank and Kelly point, the -2, -3, to translate each of our green points that we have here. So for this first one, we're going to go to the left 2, and then down 3. And then that's our point. Then we're going to take our second green point, and we're going to go to the left 2, and down 3. And then our last point, we're going to go to the left 2, and down 3 points. Now we're going to connect our red dots. Again, making sure not to hit our asymptote over here on the left-hand side. And that is our graph. We already said our asymptote is -2, but again, we don't just write -2. If you do that, it is wrong. It needs to be x equals -2. Our domain is going to follow our asymptote, so it's going to be x is greater than -2. And the range in this case is what is all reals, because you can get any number out of this that you want. Okay, the next one is exactly like that. Try this one on your own and come back for the explanation in a moment. Okay, I have this partially done for us. We find our Hank and Kelly point, which is 3, 0. There is no Kelly in this case, which is perfectly peachy. We do our base function of y equals log base 4 of x. And then we translate that, or we manipulate it into an exponential function. So 4 to the y equals x. We're going to be plugging in 0, 1, and 2. So 4 to the 0 power is 1. 4 to the first power, 4. And then 4 squared is 16. I've already drawn the asymptote here in blue. That is our x equals 3, because again, that's our Hank point. So we're going to graph 1, 0, 4, 1, and then 16, 2. It's going to be way off the graph here. And then we're going to take into account the translation we need to do. We're moving 3 to the right each of these points. So 3 to the right, 3 to the right, and then 3 to the right. Then we draw our graph through our red points here. So what is our domain? Our domain has to be dealing with our asymptote, so x is greater than 3. Our range, we can get any little number we want out of this. So our range is all reals. Okay, next one. Biologists have found that an alligator's length L in inches and weight W in pounds are related by the function L equals 27.1 times the natural log of W minus 32.8. So A, what is the length of the alligator if the weight is 357 pounds? B, what is the weight of the alligator if the length is 105 inches? Okay, give this one a try. Come back for the explanation. Okay, so the answers are here boxed in green, so if you have those, you can continue on to the next slide. If not, here's how we got them. So for part A, I plugged in the 357 pounds in for the W. Then we did the natural log of 357 here in blue. And we got 5.878. Then you're going to take that and multiply by the 27.1. We get 159.2938. And then we subtract off the 32.8 at the end to get 126.49 inches. Okay, the second one is what most of you seem to be having trouble with, those of you who I worked with on this one today. So we plug in 105 inches in for the L, because that is our length, and then equals 27.1 natural log of W minus 32.8. At this point, what I told some people is you need to think of this natural log of W as a big old X. You want to solve the equation for natural log of W, because right now you can't do anything else with it. So we're going to add 32.8 to both sides. We end up with 137.8 equals 27.1 natural log of W. Again, thinking of the natural log of W as a big old X. So how do we get X by itself? Well, you divide both sides by 27.1. We get 5.0849 equals the natural log of W. So that says, hey, what do we do with that now? And we think, oh yes, we need to write it in exponential form. So natural log has a base of e. So over on the right-hand side, we wrote it in black as e to the 5.0849 power equals w. Plug that in your calculator, and you get a weight of 161.56 pounds. And again, pounds is abbreviated as LBS. And that is your answer. Yay! Almost done. Okay, next one. We want to expand the expressions. So give these all a try and see what we get out. There we go. Okay. When we are multiplying in logarithms, that means we are actually doing what? Yes, addition, because when you're multiplying, you're adding. Makes perfect sense. So what we have here is we have the natural log of x plus, now to bring and deal with the exponents, we're going to bring that 2 in front of the natural log in this case. So plus 2 natural log of y plus, and again we're going to do the same thing here with that z, and do 3 natural log of z. And that is our answer. Not too shabby there. Okay, next one. Got a whole lot of stuff going on here. We got exponents, we got multiplication, and we have division as well. So we have log base 3. And the first one we're going to do is this 6, so just 6. And then plus, because we're multiplying, we're going to bring this 4 out in front. So 4 log base 3 of y. And now because we're dividing, we're going to be doing minus 8 log base 3 of x. And that is our final answer. Okay, for letter C here, we have even more going on. We got lots of stuff here. So we have log base 2 of 4 from the top plus 5 log base 2 of x. Now we're getting into a division, so it's going to be minus 9, oopsie, log base y, sorry, log base 2 of y, and then minus log base 2 of w. And that is your answer for the expansion problems. And now for the condensing expressions. This is a natural log, so we write natural log. We don't need to worry about a base. We have a plus, and then we have a minus. So I know there's a minus coming up, so I'm going to write a fraction sign. So we're going to deal here at the beginning. We have a 7, so 7. There's a number in front, so that, remember, is an exponent. So this becomes x to the 4th. And then it's minus, we're going to bring this 5 again as an exponent, so it's all over y to the 5th. And you're done. Part B here is a little bit longer. Again, I see a minus sign, so I'm going to put a fraction sign in right away. So log base 5. Okay, we're multiplying, so we have 10, and then x to the 4th, y to the 3rd, and then divided by z to the 8th. And those are the condensing questions. Okay, this is using your change of base formula, just using your calculator. So we're going to be doing log, sorry, almost dropped my iPad there. So we have log of 68 divided by the log of whatever the base is, in this case 5. So in your calculator you do log 68 divided by log of 5. And you should get an answer of 2.622. And you usually want to, 4 decimal places. I didn't even read my own directions there. So it's 0.6217 would be our answer. Next one would be log of 456 divided by log of 19. So log of 456 divided by log of 19. And we get out 2.0793. And then our last one, log of 1568 divided by the log of the base 42. So log of 1568 divided by the log of 42 gives us 1.968. Woo. I said 6. I did not write a 6. 9685. And that is your answer. Number 17. The intensity of the sound of a trumpet is 10 to the third watts per square meter. Find the decibel level of a trumpet. Use 10 to the negative 12th as the I sub 0. And here's our formula. Sound intensity. L of I equals 10 log of I over I sub 0. A couple different ways you can do this problem. We're going to do 10 log. Our I in this case is the sound of the trumpet, which is 10 to the third. And then our I sub 0 is 10 to the negative 12th. So now we're going to have 10 log. Here we have 3 over a negative 12. What do you do when you have an exponent over another one? Ah, yes, we subtract. Maybe that's where we got the dividing parts right for the logarithms when we do the expansions and condensing problems. Is right here, this philosophy. So we do 3 minus a negative 12. That gives us 10 to the 15th. Now think back, this is just a basic common log, so what's its base? 10. That's correct. So we're asking 10 to what power is 10 to the 15th? Well, remember last week or earlier this week, I can't even remember when we did it, but I said that we called these when I was in high school White House problems, because if we have 10 to the x equals 10 to the 15th, what does x have to be if they're equal? Well, what's the color of the White House? The color of the White House is white. So 10 to the x equals 10 to the 15th. X has to be 15. So that's what's going on here. All of this becomes 15. We still have this 10 in front. So 10 times 15 is 150. And our label in this problem is decibel. Decibels. That is your answer. Okay, one last problem. If you're still watching this, if you come in tomorrow and say, waka, 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 and if you can tell me where that is from, you might have to ask your parents for that one, where waka, waka, waka is from, then you will get extra credits. Okay, a biologist is researching a newly discovered species of bacteria. At time t equals 0 hours, he puts 100 bacteria into what he has determined to be a favorable growth medium. 6 hours later, he measures 450 bacteria. Assuming exponential growth, what is the growth constant k for the bacteria? Round k to 2 decimal places. Use the formula y equals p e to the kt. Okay, see if you can figure this one out. This one's a little bit more challenging because I don't think we covered anything exactly like this during class. So give it a try and come back and see the solution. And this is our last problem. Yay! I'm excited. I want to go home. Okay. So our y is our ending amount. Our ending amount in this case is 450. So that's going to go in for the y. Our p means the same thing it does for those compound interest problems we did at the beginning. It's our principal. It's our starting amount. So how many bacteria did we start with? There it is, 100 bacteria. So that is our p. And then we have e. We don't know our k. And our time in this case is 6 hours because 6 hours later. Okay, so we need to get our e by itself. We are going to divide both sides by 100. So 450 divided by 100. Do not use a calculator. This is another power of 10. There is no reason to use your calculators. You're dividing by 100, so you move the decimal over 2 places. So it's 4.5. Equals, on the right-hand side, we're left with e to the 6k. Wow, that looks like a log problem kind of thing there. Maybe we should write it as a log. Well, it's a base of e, so that means we're going to use the natural log. So the natural log, again, you don't write the base e, but maybe to help you guys remember, I'm going to write it here. Natural log of base e of 4.5 equals 6k. So, get your calculators out. What is the natural log of 4.5? It's 1.5 equals 6k. Divide both sides by 6. And k equals 0.25. K is a constant. It is not actually a value of anything in particular, so there is no label on this one when we're trying to find a k. So our k equals 0.25. And that is your answer. That is your review guide. Hopefully this helped out. I know in class today was a little crazy, so hopefully these explanations will help you out to study for the quiz. And good luck tomorrow, or today if you're watching this in study hall, before you take the quiz. Have a marvelous evening.